Good morning, ladies and gentlemen. My name is Alfredo Austin.
And I'm Jacqueline Hermione.
We're from Santa Rosa High School, and today we're going to discuss about our research about the potential study of biodiversity of Indonesia medicinal plant as an inhibitor agent of PARK7 for Parkinson disease treatment using in silico method. Our research began with background. We realized Parkinson's disease is rarely discussed in Asia. It is also a genetic disease that usually occurs in old people. The disease itself happens because there's a misfolding of alpha-synuclein protein, which resulted in the degeneration of dopaminergic neurons in the compacta of the substantia nigra. Secondly, the mutation in PARK7 or DG-strip1. It is also one of the causes of Parkinson's disease. The mutation on PARK7 itself will result in the loss of function on DG-strip1. The mutated DG-strip1 protein itself will cause degeneration of neurons in the substantia nigra, resulting in Parkinson's disease. Thirdly, Indonesia biodiversity. Indonesia is an archipelago with more than 11,400 islands, rich in natural resources. This is related with the biodiversity, which is the diversity of species, genetics, ecosystem in an area like Indonesia. We also was inspired by Indonesian housewife that uses traditional medicinal plant to create a medication like jamu. This inspires us to find out the potential plant diversity rich in secondary metabolites. Lastly, we use in silico method instead of in vitro and in vivo method for early discovery because it is more rapid, accurate, and inexpensive initial method. Specifically, we use the computer-aided drug design or CADD that will assist us in discovery, toxicological evaluation, and visualization. The purpose of our research is to test the potency of secondary metabolites compounds in Indonesia medicinal plant as an alternative treatment for Parkinson's disease using in silico method.
Now we move on to the methodology. This is our procedure step in retrieving the data. From the process, we retrieve several data. First is the result of the docking of reference ligand. We validate the data by using the parameter of RMSD smaller than 2 angstrom and negative binding energy. The ligand reached 1.94 angstrom with energy binding negative 3.86 in these positions. Next, we have the result of the docking of candidate compounds. The docking shows that anthocyanin is the best candidate as it has the least value of energy binding and it is more negative than the binding energy of reference ligand. The absence of energy binding of a bunch of candidate compounds shows the difficulty of finding the right treatment for Parkinson's disease even until today. These are the interaction of best candidate compound with the receptor. There are no hydrogen bonds from the reference ligand, which supports our first argument of difficulty in finding the right treatment for Parkinson's disease. We also want to validate our anthocyanin as our best compound by comparing the position with the reference ligand. Slight difference shows more similarity.
Now I'm going to talk about the result of Ramachandran plot. So basically, the rules are there are 3 different observations, such as the highly preferred observation, and questionable observation. A good protein structure is when 90% of the amino acid residue is located in the highly preferred observation. Using the docking result of anthocyanin, we see that 196 amino acid residue or 95.480% is located in a highly preferred observation, which means that it will result in a good protein structure.
These are the plants found in Indonesia that contains the flavonoid groups. There are CADD leaves, kelor leaves, and hahapan. And then we proceed by putting anthocyanin and other 2 best candidates, which is flavonone and isoquinoline, to the Lipinski rule of 5 parameters. These are the parameters that is needed to be fulfilled in order to be a drug candidate.
In the last examination, we have the ADMET or absorption, distribution, metabolism, exertion, and toxicity examination. There are several examination that is placed in this task. However, we take a look at the last task, which is the toxicity. We can see that all of the resulting a maximum tolerated dose in a positive, which means that it could be possible to be consumed without side effect, and the LD50 is located in between 500 to 5,000, which means that it is in a mild toxicity level. Now we will talk about the conclusion and the future work. In conclusion, we can conclude that biodiversity of Indonesia plants have the potential to become drug-inhibiting expression of the PARK7 mutation. And in the future, we hope that researchers can continue the in silico method by performing molecular dynamics to stimulate candidate ligands in a realistic state. Thank you for listening to our presentation.